In example 9, we're going to use the squeeze theorem, and we're going to discuss the convergence of the sequence a subscript n, which is equal to n factorial, divided by n to the power of n, where n factorial is equal to 1 times 2 times 3, all the way to n. Now in step 1, if we take a look at this sequence formula, we can see that both the numerator and denominator approach infinity as n approaches infinity. However, we have no corresponding function to use with L'Hopital's rule here. X factorial is not defined when x is an integer. So what we have to do is, we need to look at this and write out the first few terms of the sequence to see what's happening. When we plug in n is equal to 1, we get 1 factorial over 1 to the 1 power, which ends up equaling 1 divided by 1, which is equal to 1. If we plug in n is equal to 2, then we get 2 factorial divided by 2 to the second power. 2 factorial is 1 times 2. 2 squared is 2 times 2, which gives us 1/2. When n is equal to 3, we'll see that we get 3 factorial divided by 3 to the power of 3. And so that's going to equal 1 times 2 times 3, divided by 3 times 3 times 3, which is equal to 2/9. Now, if you take a look at this sequence here, take a look at the numerator. So we have 1 for the first one, then it goes 1 times 2 for the numerator when n is equal to 2, and then it's 1 times 2 times 3. So we can see that part of this formula in the numerator goes from 1 times 2 times 3 all the way to the value of n. And then in the denominator, we have 1 to the 1 power, so that's 1 to the 1 power. This is now 2 to the second power, 3 to the third power, so that means we have n times n times n all the way to n. So what that does is it's going to create our formula for 6. So this is our sequence a subscript n, which is equal to 1 times 2 times 3 all the way to n, divided by n times n times n all the way to n. So it appears from these expressions and a graph that the terms are decreasing and perhaps approach 0. Now to confirm this, we observe from equation 6 that if we take out and factor 1 over n, then that's going to equal 2 times 3 all the way to n, divided by n times n all the way to n. So notice that the expression in parentheses is at most 1 because the numerator is less than or equal to the denominator. So now we can apply the squeeze theorem. So we can say that the sequence formula a subscript n is going to be in between these two values. It's going to be in between 0 and then 1 over n, where it's inclusive with 1 over n. Now, what do we know about 1 over n? Well, as 1 over n approaches 0, as n approaches infinity. Therefore, a subscript n approaches 0 as n approaches infinity by the squeeze theorem.